Well, thank you all for coming to this hour table conversation. I'm really interested in this topic personally, and the reason is because when I was a little girl, my second cousin, Dr. Ira Skurnick, who by the way got his PhD from Michigan State University in the 70s in biophysics, he was working for the Department of Defense, and he was working with biotechnology, and I have this memory of him turning to me and saying, just talking about his job at DoD, he said, the thing that I'm honestly most afraid of is antibiotic resistance. So he's now retired, and for decades I remember wondering about what this antibiotic resistance was all about and whether I should be concerned and what it meant and what we were doing about it. And so I couldn't be more excited to be here today with our esteemed panelists and all of you to talk about the challenges and some of the solutions and what the research is involved in antibiotic resistance. So without further ado, I want to introduce our panelists. Thank you so much for being here with us today. To my left, we have Dr. James Teege. He is a University Distinguished Professor Emeritus of Plant, Soil, and Microbial Sciences and of Microbiology and Molecular Genetics at Michigan State University. He researched antibiotic resistance for more than a decade and chaired the 4th International Symposium on the Environmental Dimensions of Antibiotic Resistance just a couple of years ago. Sitting to his left, we have Dr. Sarah Comstock, who is an assistant professor in the Michigan State University Department of Food Science and Human Nutrition. Sarah focuses on the impact of nutritional status on pregnancy and infancy, gastrointestinal microbiomes, and child developmental outcomes. She also studies the impact of antibiotic exposures and diet on the gastrointestinal antimicrobial resistance genes in pregnant women and newborns. And last but not least, we have Dr. Vic DeRita, the Rudolph Hugh Professor and Chair of the MSU Department of Microbiology and Molecular Genetics. He investigates the biology and this is so hard. Genicity of bacteria associated with infectious disease. So we have some real expertise on this panel, but we're also very well aware of the fact that we have some real expertise in this audience. Antibiotic resistance is a massive topic, and our hope with our table is that as much of, if not more, of the conversation, the questions, and just this discussion in general is involved with our audience as well as us here at the table. So I'm going to kick things off with just a few questions, and then I want to encourage everyone to share their own questions, share their own expertise with us, and we'll all be listening together. So I'll begin with a question for everyone, just because I think it's a good start, and not everyone in the audience might be particularly familiar with antibiotic resistance. So anyone can answer this, or more than one of you. Why are we using antibiotics in agriculture?
Okay, so antibiotics used in agriculture primarily is in animal health and animal growth promotion. It's a well-known fact that if you feed low concentrations of antibiotics to pigs and chickens, they grow faster and go to market sooner and lower the cost. So that's one use, is non-therapeutic use, growth promotion use. Another use is, of course, if animals get sick, and then you need to treat with antibiotics. So those are the two primary uses. A small amount, a very, very, very small amount, is used on apples and pears to control blight. But that's really a tiny, tiny amount compared to that used in animals and used in humans. So those are the uses.
Okay, great. Well, I guess then the next question I want to ask is also to you, Dr. Teege. What are some of the major environmental sources of the antibiotic resistance that we're seeing?
So most of the antibiotics that we have come from soil microbes. So they are part of nature. And that's one of the difficulties, is that the background antibiotic resistance in soil is pretty high. So you isolate any pseudomonad from soil, any Burkholderia from soil. You may not know those organisms, but those are common organisms in soil. They will be resistant to several antibiotics. so the background in the environment is pretty high. So it makes it harder to evaluate, what humans do that affect the natural background. So that's one point. So the major changes that go on relative to this background are the use of antibiotics in animal agriculture. Much of that comes out of manure and then goes on the field, so that introduces new antibiotic resistance. Secondly, from wastewater treatment plants. So the human use then goes through wastewater treatment plants. That goes into sludge that's sometimes recycled on land, or to waters that go into rivers, can be irrigated back onto plants. So that then carries that cycle back to the environment and then potentially to humans. The third use, which is not practiced in the US or in Europe, but antibiotic use in aquaculture. So in Southeast Asia, much of the shrimp, the crabs, fish are grown in ponds laced with antibiotics. In fact, I was in Vietnam in a rural, basically an extension district's office, and I saw this bag in the office, and I thought it was fertilizer. No, it was antibiotics that you dump in the fish cages in the river to control disease. So that's the third big use, is in aquaculture. And the fourth environmental source that's important is antibiotic production facilities, because in many cases those production facilities don't control their wastewater treatment. So those huge concentrations of antibiotics go out in the environment, then select for resistance in those locations. Since antibiotics can be produced fairly cheaply, you can have small operations that basically follow no regulations, producing antibiotics and then leaving those into the environment. So those are the four major environmental uses. And so that's my side of this. It's not the clinical side, but the environmental side. Those four are the big ones.
That's a good opportunity to segue into what happens when all those antibiotics get into people. So moving to Dr. Comstock, your expertise lies in how early nutrition affects immune system development. So what should we know about the effects of antibiotics in terms of our health, especially on pregnant women and newborns?
First of all, if you're sick with a bacterial infection, antibiotics will save your life. So they are important. And what we want to do is preserve their ability to save our lives by preventing the unnecessary development of antibiotic resistance in humans. There's a big question mark, again, as pointed out by Dr. Tichy, about how this antibiotic resistance moves its way from the environment into human beings who may never even have been exposed to antibiotics themselves. And so we look at the antibiotic resistance load in newborn infants and their mothers during pregnancy, and we actually find a lot of resistance in these babies' microbiomes, so in the gastrointestinal bacteria that are already in these babies when they're 3 months old, 6 months old. And we don't know exactly where that's coming from, but we're hypothesizing that some of it is coming from the mother, and then as babies get older, of course, they're exposed to antibiotics. So your own antibiotic exposure history predicts a lot of what type of antimicrobial resistance you might actually harbor in your own gastrointestinal tract.
Well, and now turning to what happens when we get sick. So, Dr. Dorita, you focus on the bacteria responsible for human diseases like cholera and many common carriers of foodborne illness. We actually did an entire hour table conversation on foodborne illness and food safety. So why are we seeing, particularly in hospitals, so many antibiotic-resistant strains of bacteria?
I mean, I think primarily because we're using antibiotics, and so whenever we see that, and Jim's work has shown that quite nicely, whenever you see antibiotics, you see antibiotic resistance. And so these drugs have been widely used, and they're used in hospitals, as Sarah said. They save lives, and so it's important to continue to use them. But when we see the use of them, and if we're not monitoring the use of them, in the United States, we have pretty good control over how antibiotics are used. They have to be prescribed. There's infection control and pharmacy control in hospitals. Around the world, that's not necessarily the case, and so some countries, antibiotics are still available over the counter, and so we see resistance when we see use of antibiotics. Bacteria have evolved tremendous mechanisms to share DNA across species. The concept of a species and microbes is a little different than what we think of it in higher animals. They can share their DNA, and so a microbe that sees resistance or is exposed to antibiotics can acquire resistance very rapidly because they can share the DNA. So there's DNA for resistance in newborn microbiomes when they get exposed to antibiotics. If they get exposed, that will transmit to other microbes in their guts. And so we see resistance in hospitals because we use antibiotics in hospitals. I think that's probably the best thing.
And are some of these bacteria evolving resistance faster than in the past? Do we know?
Are they? We'll have to have an interesting discussion about it. We have evolutionary biologists here, but I don't know. I mean, you can see resistance evolve in different ways through mutation, but also through gene acquisition, through wholesale acquisition. A lot of the resistance elements are a lot of the resistance genes are on elements that can move across species and hop and get into different genomes. So I don't know if we're seeing faster evolution, but we're certainly seeing an increase in resistance that sounds like more complex problems with the antibiotics over time. So it sounds like faster evolution, but it's really, we're just seeing, we're able to monitor it so closely. And we can see, we have experiments now where we can look at hospitals. Where did this resistant pathogen come from? We can look at hospital workers, we can look in the sinks, and so we're just getting a much better handle on the in-hospital evolution of resistance.
Mm-hmm.
So I don't know if it's faster, we're just much more aware.
Yeah. Well, and more people and more antibiotics, and all this feeding on itself. I just want to pause for a second and ask, how's everyone hearing us? Okay, good. Well, I have a lot more I'd love to ask our panel, but I want to turn this to our audience and find out if anyone here has some questions or comments about what we've been talking about. Someone in the back?
The question is how are you staying ahead in this arms race? I think the issue is we're not really doing a good job of staying ahead of the arms race. We haven't had new targets in drug development for decades. We're essentially refining the targets that we have with new drugs. So this is more research. We always talk about more research. This is a real important area for more research and identifying new antibiotics that are in nature. Jim pointed out that essentially all the antibiotics that are on the market are found in nature somewhere. We've probably not tapped that potential anywhere as close as we could in terms of the genomes that we know produce probably a lot more antibiotics that we could start mining. So I think you stay ahead of it by just being aware that this problem is not going away. We thought we solved Staph aureus 50 years ago, but people are dying of Staph aureus now because we're losing the ability to control the infection. So you stay ahead by making sure you're aware you're in a war.
So I think, so now this is high profile internationally. And this was initiated by named Sally Davies in the UK, who recognized that there was an economic aspect of this. And got the economic ministry in the UK to evaluate what the cost to society would be. And it came up with a large number. That drove the UN to ask for countries to come up with their antibiotic resistant management plan. I can't remember the exact term for that now, but every country in the UN has a plan to try to manage this problem. And that's good because then each country can tune it to its own situation. When we had the international meeting that I mentioned, we had a discussion dinner with leaders, and one of the topics was, what are the issues in the high-income countries, the middle-income countries, and the low-income countries, because those are very different scenarios. And particularly in the middle-income countries now, with the antibiotic production being fairly cheap, people wanting more meat, and the use of antibiotics in meat production expanding greatly. So the biggest growth, the biggest problem area is the middle income countries now. Because remember, a serious multi-drug resistant pathogen is only a plane ride away from anywhere else in the world. And there are examples of that particular problem. So I think the point about what are we doing, I think countries are trying to do things. They have pretty good management plans for their countries. The issue is now implementing those plans and following up with appropriate oversight of those plans. That will be the challenging area.
If I can expand a little bit on your question, sort of to the broader reach to humans in their homes. For a while, we felt like we wanted to live in almost a sterile environment, that if something wasn't entirely disinfected, maybe it wasn't healthy or safe, right? And I think we're coming around to the idea all of us are covered in microbes. Right now, we're sharing our microbial cloud with the people sitting next to us. And not all of those microbes are bad for us or bad for each other. And so we have to come to terms with this idea that maybe we don't need to sterilize everything around us, but rather prevent those pathogenic microbes from causing problems for us and the people around us.
So Jim, it's my understanding that the EU has been much more restrictive about using antibiotics in farms over the last few years, and I'm wondering if there's any data available that antibiotic resistance in the clinic is going down because of that change. Is that known yet?
I'm not sure, but one thing that is known, I was involved in a study in Europe which evaluated 6 countries participated in this, and they measured antibiotic resistance genes in sewage, coming out of sewage effluent, but they also measured the use of antibiotics in those countries, and they had isolates and health outcomes in those countries. And as the hypothesis was that Northern Europe uses less antibiotics, and therefore there would be less resistance compared to Southern Europe. And that was supported by the data. The clinical data, which was the practical outcome, and then monitoring the wastewater. There's a movement among scientists now by thinking that the way you monitor this is basically in the wastewater, because that reflects then the population's behaviors. Yeah. So I guess the point is that because of less use in Northern Europe, they see less problems in Europe.
You're asking about breeding out like fungal sensitivity?
And how we're treating plants too, in this particular case, right? So, and quite well that, radio's and hives and things like this, when they have been hit on certain infections. And so all of a sudden, we're getting closer to what you see now is different than what does that do?
It's actually a little hard to hear what your actual question is. It sounds like you set up a problem with breeding resistance or breeding sensitivity breeding away from sensitivity, but then what's the question about that? I'm sorry.
Well, so what is that doing? And how is that? And we're talking about kind of a holistic,
Right.
And I understand the original and but how is that a basic beginning, if you will, of the food aspect affecting what we're seeing overall? Because we talk about that microbiome, we talk about microbiome, well, that's what the treatment that is.
Yeah. So the question is, have we seen any difference in exposure if you're breeding out resistance? I guess you'd have to hear from a plant biologist about those breeding. I don't know.
I don't know either. But one thing I would bring up with regard to plants, it's a little different aspect on this, is the fungal side. Because usually most of the plant diseases are on the fungal side. And what we're talking about here is antibiotics against bacteria. But the antifungals, the triazole class of antifungals is used widely. And and the use of it is increased over time. And what I'm told by plant pathologists is they have different tanks mixes, so they change the composition of the triazoles to try to keep ahead of the resistance. Where this has become a problem now well, it may not be directly connected, but the problem in humans is that the triazoles are also the best treatment for aspergillosis in the lungs, fungal disease in the lungs. And now they're seeing resistance. And those are the only treatment that they have for humans. Is that coming from the extensive herbicide use of triazoles? My opinion is probably not, because the biology of fungi are so different than of bacteria. So that resistance that you see in the field with fungi is not being transmitted to the Aspergillus fumigatus that infects the lungs. But it does raise this different biology of the fungi versus the bacteria, and then the very different uses in the plant world of the fungicides versus bactericides.
And do we have any plant biologists or plant geneticists in the audience who can weigh in? In a building like this, it seems...
We're in their building.
Yeah.
Jesus, slide before you do. We have tribologists, biologists, we have nematodes, people might say that iodine plants. How do you think this will factor in the round of iodine society? We have a counter.
No, I didn't get the question part of it. I know it's about...
Come on up.
We have bacterial, fungal, nematodes, as well as bacteria. They are all playing in this microbial science environment is talking about agriculture.
Right.
How do you think they factor into this process?
I think probably not in a very significant way, just because this resistance problem is with bacteria, and the use of the antibiotics in plants is so minor that even if there is some demonstrated relationship, in terms of the big scale, it's still very minor. It's like 0.01% of the antibiotic use, probably less than that, is used in plants. I would point out, maybe some of you saw recently the decision made with regard to trying to treat the greening disease in the citrus and to allow antibiotic use for that, which was big pushback from the people concerned about this, because this could make a much higher use. But the problem is the effectiveness of the use of antibiotics in the trees is so low that I don't see it beneficial. But of course, if people try to use larger and larger amounts to try to get the benefit, then that's a big problem.
What impact do you feel the veterinary directive is going to have on helping to slow down that nature of bacteria, or to help that antibiotic resistance?
I can just say from observations that we've had in the infants and the pregnant women, the most abundant and the most prevalent resistant genes are tetracycline resistance. And we don't really use those in humans or pregnant women very often. We mostly use that in agriculture. I think it's like 44% of the agriculture use of antibiotics is tetracyclines. So at least from these observations, it seems like that agricultural use is transferring to humans. And so if we can cut down on that agricultural use, we can prevent some of this resistance spreading to humans.
So you think the BFP might actually have some good results now instead of just being
It absolutely should. I mean, if you look at the problem in its extremes, as you reduce the use of antibiotics in high yield activities like farming, it should reduce the exposure to people. There was a study done some years ago with Campylobacter in chickens where there's a lot of resistance, fluoroquinolones in particular. And the other side of the question that we have is just the fitness cost of antibiotic resistance or the fitness benefits of antibiotic resistance. It turns out that fluoroquinolone resistant Campylobacter colonized chickens better than fluoroquinolone sensitive. And so the question then is the animal selecting the antibiotic resistance even in the absence of the use of antibiotics? And so certainly not having fluoroquinolones used in poultry or other growth promoters in poultry is not a bad thing, but it doesn't necessarily mean the problem will go away because we have to understand the full scope of the evolution of resistance.
So this topic is one that I'm very interested in from a research point of view because we're doing a national experiment. One has been done previously in Europe, especially in Denmark, where there was good data collected. Now we're doing one in the U.S., and now China is doing one. So in China, as of January 1st, there was to be no production of antibiotics for growth promotion. And by the end of this year, China is supposed to not use any antibiotics for growth promotion. So there's another experiment going on there. So we have one in the U.S. beginning in 2017, one in China beginning in 2020. So hopefully...
It's going the right way.
Yeah.
Is there a broad assessment of, in agriculture and human health, what amount of antibiotic use is actually deemed unnecessary? What percentage of applications in both situations would be considered not?
I don't know. The growth promotion, but I do know there was a very nice study done by a Chinese environmental chemist on measuring actually the antibiotics in rivers and streams and calculating back and so forth about the use in China, which is really high, actually almost as high in humans as it is in animals, but much higher than the U.S. and certainly much higher than in Europe. So most of that would be excess use. But how much really is excess? One thing I wanted to bring up here is there's now an initiative, and maybe some of you from the animal science area know about One Health Certified. In the food science area, One Health Certified. That does not mean no antibiotic use. One Health is the consideration of the antibiotic issue in humans, in animals, and in the environment. And One Health Certified means that all of those are considered together for the optimum use. So appropriate use in humans, appropriate use in animals, and then appropriate consideration of not environmental contamination, excessive environmental contamination. And part of this is based on the fact that in animal agriculture, some people want no antibiotics, and there's this NAE, no antibiotics ever in meat. And that's probably, from my perspective, not good, because it's known then that you have about 20% of the animals get infected and then can't be marketed that way, but then they are used in other ways. And so that also spreads then the resistant organisms too in those unhealthy animals. So the One Health Certified is trying to counter that it is appropriate to use in a sick animal, because for animal welfare and for controlling the spread of infection, that's better. And that's what you want.
The social dimensions to this seem so huge. Scientific considerations are obviously really important, but you're reading an article lately about pharmaceutical industry is just really not coming forward with new kinds of antibiotics, at least in any way that keeps up with the pace of resistance problems. So at what point do we say we've run out of the arms that our colleague has mentioned? This arms race is no longer a race because you are no longer any arms. Where does that leave us? What's the timeline for that? Would you say? Is it now?
It's now for sure. There are, so the drug companies, the profit margin is very small on antibiotics, believe it or not. Like you think that drug companies are suffering in any way, but they are in antibiotics. The profit margins are low. That's why the CARB-X program was developed as this partnership between the government, the U.S. government, and some large and many smaller drug companies. But some of those smaller drug companies now are going out of business as well because the business model is also something that we're fighting against. If these groups can't make money off of making these drugs, they're not going to be made. So there is going, I think, there's discussions already about turning this into a national, the U.S. government supports and pays for the production of new antibiotics without a profit that's going to be made, because where else is that going to come from? I mean, Novartis 2 years ago closed down their antimicrobial resistance studies, and this is one of the largest drug companies in the world. So I think we're already on that trajectory of the source of the funding for this is going to have to come from something perhaps other than the market, because the market's making the decision.
I think there still might be room for behavior change just amongst those of us who are healthy out here in the world. Over 3 million people will suffer from one of these antimicrobial resistance infections this year. But that means there's a whole lot of us who never have to experience this and don't really understand what it means for people who do have to experience that. And so when we go to the doctor with our sore throat and we're not feeling good and we're convinced that antibiotic is going to make us feel better in 24 hours, we put a lot of pressure on our healthcare providers to provide that to us, and some will stand their ground, and others, they have patient satisfaction surveys, etc., that they are dealing with, and so they'll give you that antibiotic. So I think sharing this information with your neighbors and your friends and as many people as possible is actually helpful, and a trend towards more judicious use of these antimicrobials is a really important movement that everyone can play a role in, that we don't have to wait for a pharmaceutical company to necessarily save us or our friends.
I know enough about antimicrobial resistance to be dangerous and ask silly questions. So, is there any thought about anyone looking at, maybe they already have, had the extra dosage is given to animals for this or humans for this, based on whatever they're infected with, the bacteria causing their infection or what have you. And I assume it's been kind of like the Dairy Research Council guide. They go through all these years of studies. These are our recommendations. Has that been reevaluated to see, are we just giving way too much when we are giving?
Well, certainly in hospitals they keep regular, very close control over what they're giving and how much they're giving, because they're paying very close attention to which bugs are in their hospital. So every hospital has a table, a chart. Their infection control people know what those hospitals are dealing with, which pathogens, what the minimal inhibitory concentrations of the antibiotics that they're sensitive to, and that's what drives the use of how much is used and which ones are used.
But is that science updated constantly about the minimal amounts or the maximum? You know what I mean?
Yeah, I mean, this is the MIC is a controversial number, but it is something that hospitals pay very close attention to, so that they're using the right amount and not more than is necessary. And they're worried about always running out of the ability to use a particular antibiotic because they've generated so much resistance. So I think those things are monitored pretty closely. I know they are very closely in hospitals, not just on a yearly basis, but continually. What do we have in this hospital? This is what the hospital infectious disease groups do. What do we have in this hospital? What are they sensitive to, and how much? So I don't know if
so you're basically saying the scientific data is being collected by scientists at the hospital that can be evaluated, as opposed to the science done out in universities and stuff, saying, okay, this is going to take this much, and really overestimating our science in the past.
Yeah, as I said, the minimal inhibitory concentration as a use is controversial because it's done in a particular way with a particular growth media, and so are we using the right media to test it? And in fact, when we use different media, we find that we get different outcomes, and so there are controversies around it. Scientists have been very vocal about that. The MIC on tryptic soy agar for drug-resistant bacteria is is a very potentially worthless number because inside of an animal or inside of a person, the resistance may be, or sensitivity may be much greater. And so those are the numbers that we really need. And so certainly that's informed by science, but at the same time, having those data on a regular basis in hospitals, that connection between what scientists can say, this is how we can really measure this, versus what you can actually do on a regular basis in hospitals, is they're two good things. But the points are good.
But the other aspect of this is not the amount, but the length of the antibiotic use. And maybe many of you remember that when antibiotics were prescribed, it was you should take all of those, and there was a 10-day dose, right? Everybody remember that? You take antibiotics, take them all. That was never scientifically determined. And recently there was a study in the UK to evaluate that length of dose, and it turned out to be not appropriate. So now some physicians are making different recommendations. It may be 5 days, maybe 7 days, depending on what the condition is. But in the past, this 10-day dose take everything was probably over selecting for resistance.
So that could be a big impact if you take all these little things. You know how the activity works out, right? And so we got all these little things. So I guess to keep it simple with the type of thing, and I'll go back and check, double check all the simple things. I guess that's just my body.
And I just wanted to mention that there are groups using animal models of resistance and looking at various antibiotics and which bacteria they're killing in mice that have been humanized. So basically the mice have a human gut microbiota and they're giving them these antibiotics at different doses, different lengths of times, just to try to start to understand which of those conditions lead to the most antibiotic resistance in those microbial communities. So there are people doing this on a basic level.
So I have a question or thought about sort of the strategies of combating resistance. And historically, I think a lot of antibiotics were chosen and became widely available because they were broad spectrum. Because they killed all kinds of things when diagnoses took longer and so on. And now there are groups exploring things like bacteriacids and killer particles that bacteria make to kill other microbes that have much more specificity. Or even using viruses that attack bacteria. Those, right now, they seem sort of like niche ideas that sort of the scientists are exploring. And I wonder what any of our experts think. Are these going places, or are they really more the academic kind of exception that's exciting but maybe doesn't have the marketability or whatever it might be?
Yeah, so I've been in a few discussions about this. From a planning point of view, this makes great sense. You have a specific antibiotic for this treatment, and you use that only, not these broad spectrum. That's the way it should go. But there's no market for that. That even makes the market smaller. So
how about within the context of this political movement, though, to fund antibiotics through a different channel? Maybe that would allow the opportunity then to implement that strategy.
Yes, yes.
The other issue with that strategy, it's a great idea. If you think of precision medicine, that the ultimate precision medicine, we're going to target a particular strain, not all gram-negative. The issue is clinically, in some measures, because often the antibiotics are applied before you know what you're after, and you have to go over a broad spectrum because you're trying to get a lot of different things, so the patient survives until you get to know what exactly you're after. So that gets to research on detection and rapid detection and things like that. But it's something that a lot of, certainly we do find it really exciting in academic science to figure that will be precision targeted therapeutics, and there are people on this campus that are doing that. But as yet, the clinical issues are still very real. To be able to say, we're going in with broad spectrum until we can say, get the patient right.
I would say that animal agriculture may be the place that drives this, because if you have a large herd of pigs and you want to identify early the disease, what the disease is, what the resistance is, and you have a device to do that, you would do it. That's easier to potentially sell than it is in the human side.
Can I comment on Richard's question? So I'm currently on a DoD panel, and the whole panel is for grants based on phage therapy. And so really, there's multiple grants trying to develop phage as alternate to antibiotics. Many of these are actually in clinical trials. So I don't think it's just a niche thing. I mean,
Yeah.
people are really trying to move this forward into the field. And, you know, there's now been, I think, 10 or 20 people who have actually taken phage and got their, you know, they had infections that couldn't be treated with antibiotics, and a virus was identified and taken and actually cleared out the infection. So I think there's a lot of momentum moving towards that area.
Yeah, and just, if you haven't read the book, The Perfect Predator, I recommend it. It's a story of somebody treated one of the first phage treatments a few years ago, an academic in San Diego who had been infected with Acinetobacter in the Middle East, came back and they used phage therapy to cure him. It's a perfect one. Yeah.
Kind of common to the discussion right now, just happened. So a major use of antibiotics is for surgery and operation. So for that, you have to be with a broad spectrum. And another question to the panel is that, what do you think about the preventive use of antibiotics for humans? So there, for example, give an example, a child got infected with virus. So the child shows the symptom of virus. But if you're living in a dirty environment, so there are a lot of opportunistic pathogens floating around. The disease with virus may actually make a child weak, so he can get infected by that bacteria. So I think some will just give the antibiotics to the child in advance. So in that way, that helps the child in the long run. So do you think that makes sense at all? Or?
For that individual child, that choice might make sense. You may prevent a bacterial infection in that child. But from a community and a population standpoint, it's a bad idea to give preventative antibiotics in that manner, because you're basically introducing to the environment more particles that could spread that antimicrobial resistance around if the child develops any. So in that sense, sort of preventative use of antibiotics, except for in the case of something where, you know, you're cutting someone open and their bloodstream is exposed and there's a very high likelihood they'll have a big problem with their bacteria there. It's not good stewardship in a sense.
Yeah, and that also should be driven by data, because we know there are some viral infections that absolutely predispose to bacterial outcomes, in which case maybe that's a reasonable thing. But to say, well, the child's immune system is weakened because it's got a viral infection, let's just give it antibiotics without evidence that that viral infection leads to combinations of lung infections. That we know that there are high likelihoods that there may be an infection later on, but just to say that there's a viral infection might be in a weakened state or exposed to pathogens, I'm not sure physicians actually do that. I think they do it based on what's known in the clinic.
Yes, I think that's something that we have to explore, because in the eyes of the public, like for parents, they are not well informed with all those things. So their decision is based on the welfare of their own individual kids.
That's what Sarah was saying about public education.
So there's another aspect of this, and Marty Blazer, who is a very prominent person in this area, actually co-chairs the PACARB, President's Advisory Committee on Combating Antibiotic Resistance. He is of the opinion that early antibiotic use then permanently affects the immune system of the human. And so some of these autoimmune diseases that appear later come because of the early use of antibiotics and the inability of the immune system then to adapt to the microbes around it.
Just to piggyback on that, what about the concept of when you get a wound and you go to urgent care, for example, we prescribe you a lot of antibiotics and it's going to take them all. That's preventive. You don't have anything, you don't have an infection, and they don't know what you could get, and so it's prescribed you with an excess of that. Maybe that's an opportunity for everyone in this room when they're at urgent care to say, wait a second, this might not be a good idea.
Actually, that brings up an interesting point. So in the research that we do, we use some medical record data to try to track what people have been exposed to. And urgent care can be a real problem for us, because urgent care doesn't necessarily link into their medical record of that individual. And so an individual may have an exposure that's not documented when you're trying to go in and understand what types of exposures that person has had. And many of the hospital clinicians that I've worked with have suggested, just as you have, that urgent care providers are much more likely to give you an antibiotic than your actual primary care physician might be.
Or if you went to an ER. I
ER.
think that you're not, probably less likely to see that in an ER in a hospital that's dealing with antibiotic resistance than in urgent care that wants to get another patient through antibiotics.
But people don't know to say no.
Yeah.
Well, the urgent care in like Okemos, like the Sparrow, actually, fast care centers have big posters about CDC, from the CDC, the Centers for Disease Control, about antibiotic resistance, basically to educate you while you're waiting the hour and a half for your vaccine about not requesting antibiotics. But I know that this is not standard and it differs from urgent care to urgent care, and the healthcare system can be a whole nother topic for a conversation in the community.
For sort of a large-scale education effort. I know coming from veterinary medicine, we're having issues with that where clients just aren't comfortable with, yes, your dog has kennel cough, but it's not that bad, so we're not doing many things. That touched on that. We figured we sort of large education for
So I'll make a comment. I'm a nutrition science. I'm in the nutrition department, and we've known for a long time that we need to eat fruits and vegetables and whole grains and not eat cheeseburgers and pizza and whatnot. And we've told people this like forever, and no one listens to us. So I think it's very difficult. I don't know that an education campaign will be useful to change people's behavior. Behavior change is very difficult. So even though it would be great if everyone were educated and really took it to heart and applied it to their lives, I think that's not the way we're going to solve this problem.
I'll take a slightly different view on that. It's probably true, but people know that smoking kills them, and they still smoke, and they know that overeating kills them. However, if you talk to kids in grade school now, because I've done it, they're all into the brain. And why are they into the brain? Because the professional societies have gotten them so excited about the brain. And I always try to tell them, I don't think we'll ever understand how the brain works. You should think about microbes. So I think a campaign, I think we do need to be better at getting people. I was in a cab a few years ago, the day that they got the Higgs boson. Remember when the Higgs boson was discovered? The cab driver was telling me about it. I don't think he had any clue any more than I did, which was nothing, about what Higgs boson was, but he was talking about it. So I think getting things out there, and certainly getting the idea that the things you're eating may have been exposed to antibiotics that may kill your children, is not a bad way to start discussions and get people to think that this is a problem we should be thinking about. So when you go to urgent care with a wound, you're not thinking about the Higgs boson, you're thinking about, hey, I heard about something with antibiotic, or this is a good thing. So I think education is probably at least worth trying. And it involves us, it involves our professional society, it involves a lot of different sort of frontline people in schools and other places.
Well, we're talking now about social science and communication, and we had someone stand up a lot earlier and say some of this is a social science issue. So it's a good opportunity to bring up that now that we're roaring into the 20s, Food at MSU wants to include Twitter in the conversation to be able to reach people outside of this very echoey atrium. So I want to ask a question to our panelists and to our audience that we received from at Alan Levinowitz, who happens to be a science writer and author on issues like what's in our food. He posed this question: what can we do about the overuse of antibiotics with contributing to a general suspicion of, quote, chemicals and big medicine? Or we can leave that one out there.
Could you repeat that?
What can we do about the overuse of antibiotics contributing to a general suspicion of chemicals and big medicine? So we have a lot of people very suspicious of science, some with very valid reason.
So is that from the opposite side? So people who are afraid of antibiotics?
I think what he's saying is, there are people who feel like that this is these drug companies have conspiracies, or the chemicals in our food are killing us. So how are we going to get past that and tell them that these are the people and groups that are going to also solve this problem?
I suspect it's a lot about that and fostering trust and expertise versus conspiracy theory.
Yeah. if we continue to make movies where the drug company guys are bad guys, I think that is part of it. Anybody who's seen, what was the one-armed, the doctor, the Harrison Ford movie, the whole thing predicated on drug companies being bad guys, you know, so, I forgot what it was. The Fugitive. What was it?
Fugitive.
The Fugitive, yeah. So that the bad guy was a drug company guy. So I think that doesn't help. Even though we may all think they're bad guys, if we're putting it out there that these are the guys that are killing us, then that's where that question comes.
Yeah, along those lines, there was just a New York Times article on the economics of antibiotic resistance. Did you see that?
I didn't see it, yeah.
Yeah, it was talking just what you were talking about, how, you know, the economics are not there and these companies that have developed antibiotics are going bankrupt. And I read the comments section, and most of the comments were from people like, oh, these drug companies are just trying to make a bunch of money, they're evil, and, you know, so that is a big issue, I think. I think that's a valid concern.
I mean, I don't think we can discount the fact that drug companies are trying to make money. They're not necessarily in the business of making everyone's lives better. And that since we need to rely on our government to do some of that, right? That's what governments are for, to protect all the people and not just make money. So we have to, you know, use our abilities to get governments that are willing to do those types of things for us.
So, question, one comment with respect to the whole range of, if you had a capital audit, what could be something. You know, you got us a sandwich, and I appreciate the lunch. It could have been whole grain bread. And if we don't start making those little steps, the kids will make this little secret. That should have come. But, now, two questions. One would be, in respect to feed, the location of the feed in respect to, say, swine flu and pigs. In working with agriculture, we really find that location makes a difference of incidence. So the closer the feed is produced makes a difference. And so how much research has been done on that? Then the other thing that sort of touched on, you realize there's I think prevention is the bigger side that we can work on. And this other thing, we're playing catch-up ball game, the resistance, and it's about. But I commend you for it being in there, but we've got to do some prevention. So as we learn more about soil health, and if we really change the dynamics of the soil, what you said about fungal organisms, that appears to be one of the key things that's missing. The system is pretty much nitrogen bacterial dominated. And eating up organic matter and going in the wrong direction, taking more chemicals. We need that fungal soil organic matter building component, but we don't need to improve it from way down here. We need to put back where it should have been, which brings us a whole new ballgame of what we're doing with the food system. So two things. One, location, which I think is affected by the environment. And then second, if we change the biology of the food system, and the soil health thing is starting to be addressed. So I think that this change is going to come.
Yeah, I would agree. And certainly much more recognition of soil health and what contributes to soil health, you know, in the last decade. So a lot more motivation in that direction. And that also, the core there is carbon, or organic matter, to establish those healthy soil microbiome. And that also then, from a CO2 and climate point of view, is beneficial. So it's beneficial in lots of ways.
Well, from your perspective, what measures should we be taking at the policy level to address antibiotic resistance? I mean, we can all think about when we're taking antibiotics and when we're using all of those sanitizers that are now next to all the soap dispensers in every restaurant. But what should we be thinking about at the national and global scale to address this?
Can I just make, so those hand sanitizers don't work in the same way as antibiotics work. So those hand sanitizers chemically kill the viruses and bacteria. They do not contribute to antimicrobial resistance because of the way that they work. So They do kill your skin cells, which may put you at more risk for a skin infection, but they actually aren't contributing to this problem. But some of the chemicals like the triclosans that they're putting in soaps and other products do contribute to the problem, just to clarify that. I think going forward, we need our government, and I think they are beginning to. I mean, Chris mentioned that the DoD has a big push to come up with these alternative therapies and support those. The CDC has a big program to try to share this education campaign with individuals about it. And so I think they're doing things, but we do need more funding for drug discovery, which is very expensive and very hard to do, which is why government doesn't like to be involved in it and would prefer for private companies to be involved in it. But we are at a point where this is such an important problem for so many people in our country that I think we need that sort of intervention.
I mean, certainly changing the use of antibiotics in growth promotion through the USDA's mandates is good. I mean, that's a policy change that's important. That's driving public perception in lots of ways. I mean, McDonald's and Red Robin now advertising they sell antibiotic-free food, which is a good thing. And that's driven by them understanding that the government and the policy makers have indicated they don't want to use those antibiotics anymore. People become aware, they demand it of the products. And so that's all a good thing. So that relates to education, just keeping the message in front of people. This is a problem that's not going away. We're going to have to just keep fighting it.
So you mentioned global, and I consider the biggest issue the global issue because these can spread so readily. And I mentioned the middle income countries before, and that's where the biggest selection is going on right now. Certainly in Southeast Asia, but it's also moving into Africa because Africa is now growing more fish. How are they doing that? With antibiotics. And I was at a meeting where one person who looks at it, from this global risk perspective, and he said, if you want to put your effort to really make an impact, it's going to be in, he said Southeast Asia, but it's basically the middle income countries that are expanding the use of antibiotics extensively and don't really have control over that. And that is in our food products. So when the food products come to the U.S., we do have restrictions on the amount of residual antibiotics. But of course, that doesn't measure antibiotic-resistant microbes. So, and I don't know what to do about that particular problem area, but it's the biggest one, I think.
I think Dr. Buehler had his hand up earlier, and we didn't get it.
Well, I think Joe kind of hit some of the things that I was going to say, but I guess I'll ask you, while you put me on the spot, ask maybe a rhetorical and almost based on a little bit reactionary question, but I get to travel in a lot of different places, and these issues of resistance are talking about them everywhere. It doesn't matter if it's insects, plant pathogens, disease, and so on. I'm not sure how I answer this question if I was sitting at the table, but has it become too difficult to develop and release new tools? In fact, with that comment, we need to figure out other ways to streamline new ways of thinking about this before it's too late.
Yeah, I think, as alluded to earlier, I think rapid detection of pathogens and of resistance is the ultimate solution. And that technology is not that difficult. But the problem, to me, relates to the market situation, because everybody sees so much big money and so much regulation, because then it gets in the human side, and then it becomes a big barrier. So we have, sort of a economic, regulatory, societal perspective barrier to really developing easy to use on-site detection methods.
And it is, Doug, your point too about this problem becoming difficult. I mean, having having the opportunity to design and develop and discover new targets for you know, like the ones Rich and Chris talked about being very precise. Can we hit just this bug? You know, to be able to do that requires an awful lot of knowledge about the bugs, and we've known their cell body proportions and constituents for 100 years. And so those are the things we have to target. Is there some new target that we can find that isn't already out there that we haven't already tried? There's certainly people who study natural products feel that we've captured maybe a couple percent of what actual natural products are out there. So maybe we'll find some new targets because we haven't explored all the products of those targets, that are targeting those microbes in the soil, as Jim pointed out. That's where the antibiotics come from. So, but that requires just a lot of researchers, groups that are trying to develop combinatorial approaches to look at natural products. But it's very expensive, and you know, you write grants on those, and there's problems. You know, it requires a real mission by the government to say, this is going to cost us a lot of money, but we need to put the resources into it. I think it's happening. I mean, the panel that Chris is talking about, people start to think outside the box. Let's go back to phage. We put phage aside 100 years ago because we discovered penicillin. Let's go back to that and see what's out there.
And I don't think we should lose sight of the conversation related to repopulating our environment. And you know, we've decimated some of these environmental areas, our soils, our bodies, our hospitals. And I think we need to realize we can actually do a lot by fixing soil health, fixing our own microbial health, and supporting sort of the healthy microbes. They can help us fight some of these pathogenic microbes and sort of reduce the load we're dealing with. So I think we have a lot of angles that we're coming at the problem from. And I haven't lost all hope yet. I don't think we're at the point where we're out of solutions. I think we can still move forward and make a lot of progress.
I mean, one of the things we're talking about essentially how can we create a healthy population, and that's not where a lot of the problem lies. It lies in a population that's not healthy in hospitals, and we're keeping people. You know, people are staying alive longer, but with the assistance because their immune systems are damaged. They've been damaged by whatever it is we're treating them for cancer, for example. So we have to have antibiotics that work in those settings because those aren't healthy people; they're unhealthy people, and that's really where a lot of the use is going to still be driven. And that's a big problem. You know, that's a real societal issue. You know, people are staying alive longer because we can keep them alive with antibiotics in settings where their immune system isn't doing it for them. So creating a healthier immune system in CRD is one thing. Creating a healthier microbial system in us is one thing. Doing that in ICU is totally different, right?
Another question I thought.
So I think that actually there are a lot of small companies and mid-sized companies that are developing new antibiotics. If you look at like FDA-approved antibiotics, it's actually starting to reverse. So the trend is they're starting to go up. The problem is the mid-sized company develops new antibiotic, and you can look at the company Achaogen, which just did this last year. FDA approved, made it to the clinic, and then they were bankrupt within a year. And so that whole like pipeline is drying up. And if we lose that entire pipeline from how do we get from like MSU lab to the clinic and all those companies disappear, then I think we're in a problem where we're not going to be able to develop new ones. So to me, like that's the biggest policy priority right now is to maintain the pipeline.
Well, I would say at this point, thank you all so much for being here, and thank you to our panelists especially for being willing to participate in these conversations, and for everyone working through this echo with us throughout that wasn't quite expected, but I think everyone's done a great job. We encourage you to continue the conversation, talk to us, tell us what kind of topics you're interested in hearing about at future Hour Table events, and we'd just love to continue the conversation going forward. So thanks again, and we hope to see you next month.